All right, so in this next video, we're looking at finding slope from tables, okay? So from tables. Now, it's the same idea as what we looked before in terms of being able to find it from 2 points, although there is a different approach that we can take when looking at a table. But in a table, okay, just like this example here, we're given an x column and a y column. Well, all of those really represent points. For example, the point 2, 5, 4, 10, 6, 15, okay? It's just given to us in a table format. Now, we can find the slope, thinking of it in terms of our vertical change over our horizontal change, or in other words, how does it change in the y as I move across the table versus how does it change in the x, okay? Now, one approach that we can take is think about it, what changes from the y to the next y? Well, this is a difference of 5, right? 5 to 10, I'd have to add 5 to get to 10. Well, same thing here. I'd have to add 5 to get to 15, okay? So the change in y here is I'm going up by a positive 5 each time. So for instance, if we were going again, maybe the next one would be 20. 15 plus 5 would be 20, okay? Then we also have to think about the change in x. Well, how do I go from 2 to 4? Well, that would be adding a positive 2. So the change is a positive 2. How do I move from 4 to 6? Again, a change of a positive 2, okay? So each time that we move across the x, we have a change in 2, okay, a positive 2. Well, we remember that the slope is the change in y over the change of x, or the rise over the run. So in this case, our change in y would be a positive 5, and our change in x would be a positive 2. So the way we would write that, our change in y over the change of x, okay, that's what this guy means here, the delta symbol change, would be 5 over 2. So my slope would be 5 over 2. That is one approach we can take when we're trying to find the slope from a table. Another approach that we can take to find the slope from a table, okay, would be using this guy that we use for the slope of 2 points. y2 minus y1 equals x2 minus x1. It's really the same idea, it's just applying the 2-point idea. Now, if we apply this, if we use this guy, m equals y2 minus y1 over x2 minus x1, all we really need is 2 sets of points, okay? For instance, I could call this one my x1, the first x, and I could call this one x2, the second x. We don't need more than just 2 points, okay? So as long as you pick out 2 points in our table here, you'll be fine. So that would be the x1 and x2. Then let's choose this guy to be, let's say, y1 and y2. So with that in mind, let's plug that into our equation there. We would have m equals y2 is 10 minus 5 all over my x2 is 4 minus 2. Well, what's 10 minus 5? 5. What's 4 minus 2? 2. So again, we get 5 halves both ways, okay? So both ways work, okay? Let's try one more using kind of like the change of y and change of x method, and then the slope formula method, okay? Well, again, when we're looking for the change in y, we're saying as I move down the table, how do things change? Well, to go from 2 to 4, I'd have to add 2. Then to go from 4 to 8, I'd have to add 4. Well, notice those two are different, but that's okay because we're going to be able to get to the same slope, and you're going to see that here. So to go from 2 to 4, I had to add 2. To go from 4 to 8, I had to add 4. Okay. Now, the change of x here, going the other way, 3 to 0. Well, that's only a change in 3, right? But be careful. I'm going down 3. Okay, I'm going down 3. Instead of going up 3, I'm going down 3. 3 minus 3 is 0. So I'm actually subtracting 3 there to get to 0. So that would be a negative 3 for change. Now, to go from 0 to a negative 6, wouldn't I have to subtract 6? Yeah, so that would be a change of negative 6. 0 minus 6 is negative 6. Now, with that in mind, again, the slope is the change in y over the change of x. We have 2 different examples here, okay? We have 2 different situations. In the first situation here, it was a positive 2 for my change in y. And for my first situation, make sure we're using the same values here. For my first situation here, it was a negative 3. Well, what would that be? A negative 2 over 3. That would be the slope. Well, let's see if that's the same thing I get for the second situation. So when we did the change in y here, it was a positive 4. So let's write that out over here. M equals the change in y over the change of x. Okay, so going that way, it was a positive 4 for my change in y, and it was a negative 6 for my change of x. Well, 4 over a negative 6, can't that reduce? Yeah, I can divide out a 2 from both, and we get negative 2 over 3. So we get the same answer in both cases. Okay? Now, that is one approach we can take to find the slope. Again, we can also apply the formula. Okay? M equals y2 minus y1 all over x2 minus x1. We can still apply this formula if you feel more comfortable with that. You just need two sets of points, okay? For instance, let's say my sets of points, I call this x1, and it doesn't matter, let's call this x2. Then if this is y1, let's call this y2. So with that in mind, my y2 would be 8 minus my y1 of 2 all over, what's my x2? Negative 6 minus 3. And we should come out to have the same answer here. 8 minus 2 is what?